Okay, so the purpose is not just to produce the measurements when you are a reviewer, but it is to validate. And I'll explain a bit more here what we mean by validate or check consistency. But it is to validate the final optical light curves that will be sent to the modeling team or the physics interpretation team. The reviewer will run specific tasks, validate, cross-check. Again, I'll explain what we mean in the process, and assess consistency between the entire light curve. And the note at the bottom here is just that some points, when you look at individual points or an individual group of points, it may appear correct, but then the entire light curve in a specific filter might not be consistent, which is what I'll go through here. So who's a data reviewer? This can be a grammar colleague or a team with different expertise or an external partner, such as one of the cases with 29A. Obviously, you must have access to the data, but as we mentioned, at least so far, it needs to be somebody defined by Sergey, specifically for the photometry review. It's conducted by someone independent from the data analysis process, which is crucial because if I'm the one doing the reduction of the images, I can't be the one doing my own review. Uh, it can provide authorship in some cases, independent of the contribution, but preferably can be someone that is already working on different parts of the paper. But the main part is that it needs to be somebody who can, on a daily basis, follow the data, because it will take, for example, for this one, we took 100 plus hours and we're still going 2 to 3 months of work on just one data set, and it requires doing a repetitive, monotonous task over and over again in the same level of care to make sure that everything is consistent. So the data can be obviously grandma data or from external partners, whether the scientific interpretation is grandma-led or not, depending on the publication. The images can obviously, if external, be requested from the photometric working team, program chair. If necessary, the coordinator can give permission to the reviewers to also contact the partner teams specifically to facilitate the review process, ask about specific parts of the images or the analysis. But the reviewer should make sure that we have data such as with 29A. It's on cloud. It needs to match Sky Portal. Need to contact Damien for KNC observations, make sure that everything is there. Need to check with the paper writing team for external, so not on OwnCloud, images. So there's data that can be communicated by email or data that's in online repositories that expire in like a week. And all of these data need to be in the end on Sky Portal, which I'll get to, and on the light curve. Because some data can get lost and some data can expire, and then there's no way to access it again. So now we get to point by point what we mean by the review. We found that the best practice for the light curve is to use Sky Portal as being the most up-to-date repo for the source data. So it should be the central place for all the photometric data, not some offline, separate file. What we did here is that if you open the page for 29A, you will see exactly as up to date as it gets with everybody who's working on the photometry. And data can be sometimes corrected, for example, additional treatments like color correction, etc. All of this should be reflected on the light curve. And if not reflected, there needs to be some comments on what exactly is reflected and what not. So what we did here, and I guess this kind of ties into what we were talking about, how to keep track of who's doing what. So what we did, you can see on the right here, I don't know if you can see my cursor, but you can see on the right here, we played around with the origin a lot. We kept track of who is uploading what data and with the date. So here it says Dahlia 3003. I uploaded the data on what date. And then when you go to the annotations, I explain what the data is. And this is important because sometimes you have the same data set uploaded by Sergey and myself, and then we're comparing both of them. And if you don't have any origin or any annotation, you'll completely lose what data is. A reviewer should also use the validation, which is the check mark or the cross, etc., to make sure that this is validated means this is done or this has been checked and reviewed. If not, then it's the reviewer's job to modify the status and to check, especially if the image was uploaded through STD Web, like the Sky Portal upload. You have the task and the reviewer should check it and then update it. Now, in the case of where images are ambiguous or we're not sure of the photometry, One of the main things that we stress a lot that should be done is visual check of the images. And this, we did this with all of the Skynet images, which were almost 500 raw frames. And that is because visually checking an image by eye can tell you a lot that will not be told by numbers or through running the photometry. So firstly, if the target is visible by eye or not, because if it's not visible and you see a detection, this could be real or not. But it's a bit trickier because this must be flagged for review because you need to then make sure if you do actually detect something or not. Visually checking the image as well can tell you that if you have a lot of point-like sources all around the image or scattered, it can indicate hot pixels or an issue with the detector. If the stars or even your actual target appears elongated and not round like a point-like source, this can lead to a problem of stacking, which means that you need to realign and restack, or an issue with the telescope mount. And also, visually checking the images can show you if you need to exclude some of the frames. So a lot of the times we ask the telescope teams to just upload the stacked images. But if the stacked image, this is a raw frame, what you see here, which is just one frame, sorry. But if the stacked image looks like it has lines or just very giant artifacts that can be a problem from just one frame, then it is the task of the person doing the analysis, but also if that person didn't notice it, then it's the task of the reviewer to then request the raw frames to be reanalyzed and restacked and remove that frame. So actually here, this was a one frame out of 30 that were stacked, and this is just the only faulty frame that should be removed. Another thing is that we did not only use forced photometry to extract the magnitude. So we also used, and I'll get to exactly what we recommend to be done for every single image, but we also used the automatic simple transient detection. In some images, like this one, which you can see already, there's a lot of patterns and fringes. You can tell already that you cannot extract robust photometry by how many candidates that are automatically detected in the image. So even if you know where the source is and the location of the source, if you run the simple transient detection and you see that you have 200 candidates, like in this image where we had 200 candidates detected, then that means that there is something wrong. It doesn't mean that the photometry itself is wrong or that the detection is wrong, but it means that you need to do a lot more investigation on why all of these candidates are being detected within this image. Another thing is the new update that Sergey did that shows you the aperture sizes. So you can see here on the left panel, you have the small inner circle, which is the photometric aperture, and then the two outer circles, which are the background analysts. And what this tells you is whether you are only taking flux from the target or if there's any contamination. So you can see in this case, there is a nearby source, and that a part of that flux is being taken into the aperture that we're performing the photometry at. And in this case, you're just contaminating the flux, so you're going to get a brighter magnitude than you should get. So in that case, again, if this was missed by the person doing the analysis, then it's a task of the reviewer to, if checking these individual images, to go through these parts, not just take the value that is produced by the forced photometry. And in this case, you would just go in and reduce the relative aperture to less than 1, and then keep checking it to make sure that you are engulfing the entire target, but not including any nearby stars. A very important point, because this gets confusing for many people, is the Vega and AB magnitudes. So Sky Portal will automatically display the photometry table in AB magnitudes, but if you're comparing the Sky Portal table to an STD Web task, if it's in Johnson Cousin filters, then you're going to be looking at Vega system. So there's a button on Sky Portal that can switch between Vega and AB for the photometry table. But then at the same time, you would need to check the Max system column so that you can actually make sure that what you're looking at is Vega, as sometimes it will not update straight away and you'll still be looking at AB even though you switch the table. And modifying an entry sometimes auto-refreshes the table and reverts back to AB. So if somebody starts mixing in AB and Vega magnitudes and you're not sure which is which, then you'll pretty much mess up the entire photometry table. So every single time that we check any point or modify any point, we always make sure like 10 times that we are in the right photometry system. Also, the results that we give into any modeling team will be in AB, so we usually would just work in AB. Another thing is the telescope names. Um, so generic shouldn't be something that is used anymore. So we used to use generic for KNC telescopes, for GCNs, etc. But now there is a telescope called KNC for KNC points. There's a telescope sort of called GCN, which is how you upload GCNs, because generic should not be a name of a telescope that is uh, put in any file that's provided to anyone like the modeling team or in the publication. So if it's KNC, then you add the telescope name in the notes, which is what we did here. And you can put the instrument as KNC, so this should be modified to KNC. And then when you don't know the telescope name, what we did is that we put the name of the observer. If there's any missing telescope, then we can just easily add any telescope like we had with Euler. It was not there, but you just add it so that you can upload the points under the right telescope. Now we get to the compatibility part that I was talking about. So what do we mean by are the results compatible? The first thing that we checked was measurements by two different telescopes taken at a time that's very close to each other at a stable time, which is what we call stable time, which is later times where there's not much fluctuations. Are they similar or not? So this was a case where we had two different KNC telescopes with just an hour between them. This was one day after the trigger, and a 0.5 magnitude difference, which is likely because one of them was in G band converted to V and another one was in V band. So this would be the first thing to check, which is the points that are close to each other in the same filter. You need to make sure, firstly, if it is actually the same filter, if it's something that is converted, and why there is a discrepancy between points that are at the same exact time or close to the same time. This is the V-band case that Sarah and Sagar were just talking about. So here we had this kind of data, which shows a beautiful curve that rises and fades. And then you have the points at the top here that were from KNC. And these to us are not compatible. And what we mean by compatible is that they, within error bars, are not reasonable. And for us, if it's not reasonable within error bars, then one of two things are happening. Either the measurements are not from the same telescope, which is the case here, which means that this difference is due to filter camera efficiency. Again, the case here because the filters from KNC were not V-band. And then up to 0.1 magnitude difference is acceptable taking in the error bars, but this is not the case here. And then the second case would be if the error bars are too small, which we did for some of this kind of data, you just set it by default to a 0.5 so that it is reasonable. And then if both of them cannot be fulfilled, then it needs to be checked by Sergey. Upper limits, we included the upper limits only in few cases. So prior to the detections, like you see here at the beginning, which was from Taro during the prompt emission. After the last detected measurement, we actually don't have that. And then the upper limit in general, it just tells you that if it's at the transient location, it corresponds to a fainter magnitude. It's just generally consistent with the expected fading that you would see at a longer time. So we only keep it if it tells us something important. Otherwise, you can get rid of the upper limit point. If the images are not compatible, so like I mentioned, you need to check firstly if it's the same filter. So L band converted to V and an image in V is not the same filter. For Sloan, it's usually almost the same, but it's not the same as Pan-STARRS or ZTF or LSST. And what we did is that we checked the color term. So the color term, this is the formula of how you have the standard magnitude. It's the measured magnitude plus the color, which is the B minus V or G minus R. And that tells you if it's a smaller magnitude, if it's a smaller value, it's bluer. If it's a higher, it's a redder color. Multiplied by the color term that you see at the bottom here, which in this case was 0.21. And if you have multiple data sets at the same time, like we did with this GRB at the beginning, this allows to determine the color of the transient. In this case, you need to ask Sergey, as he's the one who did it for this GRB, because the difference or the incompatibility of the points could be due to the lack of color correction. You need to apply a color to the data to correct it. So how we mitigated this was to also run the task without the color term. So you can assume the same color for all the stars. And then you can check Firstly, if the catalog for the calibration is the same. So for us, for Johnson Cousins, we used pan stars. If the image is deep, Gaia if the image is a bit shallower, and then pan stars for Sloan. And this is almost the same for the entire data set. You to check if one image might have a detection that's very close to the upper limit, which means that it's a pretty weak detection. If the SNR is much higher on one of them than the other, if the exposure is comparable or not, and also the astrometry, because this turned out to be a problem with some of the images that is just the astrometry is bad and it needs to be redone. So the recommendation here is to run systematically four approaches. So force photometry, simple transient detection. What we did here was that we did force photometry with template subtraction on STD Web. And if the measurement of the source isn't the same between forced photometry, for example, and transient detection, or forced photometry and with subtraction, you obtain something bigger than 0.2 or greater than 0.2, sorry, then you need to check firstly if this is appropriate for the specific task. So if you have a bright host, then this would make sense that you have a big difference. If not, then you need to contact somebody who can explain why you have a big discrepancy between the results. The criteria we set here as well is that any magnitude fainter than 21.5, we ran A, B, and D and checked whether the result that we get is consistent or if it makes sense or not. So if there's a very huge jump between the results, then something is wrong either with the image or with the way that the analysis is going. You can vary the catalog, see how the source measurements changes. Usually just the more stable that your results are, the more you're confident in what you're getting. And then we also suggest to remove any point for which the uncertainty is greater than 0.3 mag, unless you kept it for a very strategic reason. But we try to stay below 0.15 uncertainty. Also, to check for the template, templates can be added to STD Web, for example. You can add a custom template based on whatever specifications you want. So you can go to Vizier Surface and you can choose whether legacy or pan stars, etc. Choose the size of the template, and then download your own template. And in some cases, it's worth checking the upper limit of the template, so how deep it is, and whether the image is deeper than the template or not. And also, you can run the photometry at the source location in the template, for example, if you have a bright source in that location, or if it's the galaxy, just to measure what the magnitude is in the template. Galaxy subtraction, and when the case of when you have a transient at the galaxy location. So sometimes, in some cases, when you do forced photometry, you can see that there's something in the image. After subtraction, there's nothing. And it means that the photometry in the forced photometry section is right on top of the galaxy. And the flux is from the transient is very faint. So most of what you're detecting is just the galaxy flux. And to remove the flux of the galaxy, you use STD Web with template subtraction. But it gets kind of tricky on whether you're subtracting. If your transient is extremely faint, then you're not going to detect absolutely anything when you subtract it because you're going to subtract the entire galaxy flux. But this is a bit more of a extreme case when the transient is right on top of a galaxy. So GCNs and external non-gamma points. So GCNs, ETELs, Atlas are similar, is not to be used in the article and not to be distributed to any team or the modeling teams. So the only times that we used GCNs was in areas where in the light curve or regions in the light curve where we did not have enough points and we wanted to see how the evolution of the magnitude was during this time. Otherwise, the moment that the light curve is finalized, then all of these are to be removed. For example, for us, we've already removed the GCN points after 1 day because we no longer need it. So it can be useful when you don't have data, but in the end, it needs to be removed or deleted because we cannot consider it as valid. But if the review team identifies that something is important or some of these GCM points can be valuable to our light curve, then you can propose to contact these teams, such as what we did with Skynet. We had a huge lack of data, and then we contacted them based on their GCN points to include their data in our light curve. Now, non-optical, like X-ray. So X-ray also needs to be extracted, analyzed, finalized in a form that can be comparable to optical or in a form, like for example, if you look at our page, you'll see that we've uploaded the X-ray points in magnitudes so that you can also compare it and compare the evolution and the rise and the decay of the X-ray light curves. For Swift events, for example, you'll find it in different forms. You'll find the flux over the entire energy range. You'll find at 10 keV. So a reviewer's job is to identify which energy would be most suitable for the analysis. So whether to take the energy at 10 keV or convert to 2 keV, which is what we did here, as we assumed it to be a more suitable representation of the data instead of an extreme boundary. They need to evaluate the binning and whether it captures the right evolution and the rise and the decay and the uncertainty, if it's under or overestimated. Similarly, for the spectral analysis, they need to assess which parameters need to be varied and which need to be fixed. So, for example, when I was doing the spectral fitting at the beginning, and we were varying the photon index, and then upon speaking to uh, a lot of people, including Antonio, they've all mentioned that we need to actually fix it to not propagate uncertainties into our light curve. So things like this would not be identified by, or might not be identified by the person doing the analysis. So it's the reviewer's job to make sure that the parameters being fixed or varied are appropriate, and also whether any further analysis need to be conducted. For example, for us right now, what we're doing is we're trying to check if there's any evolution during the rise and the decay and before and after the flares. For UV, um, the reviewer in this case is external. It is Sam Oates, who is a collaborator of Antonio. And Muna has sent her, because Muna is the primary person who's done the analysis for the UV data. And she sent her the data that we've done, including the step-by-step process. And upon speaking to her, for example, this is just some points that you can get from a reviewer and that should be expected. She pointed us to some aspect correction failure. So we had missing points because some images are automatically rejected and you need to manually correct them. Secondly, the settling images, specifically for the V-band filter, are affected by the cathode ramp up. So she mentioned to compare the photometry of several stars in the settling image of the V-band and a later stack to make sure that is consistent. She pointed us to some bad points, which indicate that the source landed on a known dust patch, and we need to identify them manually and exclude them because these will not be done automatically in the process. And also initially, we just based on instinct assumed that some of the points that have very high errors need to be rejected. But again, as the reviewer, she told us that that would introduce bias into the light curve. So again, for UV, in this case, we had an external reviewer, but a lot of the data does need to be reviewed, although our photometry or Mona's photometry is exactly the same as what Sam has gotten, but there are still missing points and there are still corrections that need to be done. Lastly, this is just a review of some things to know. So, and some things that to sort of keep an eye out for, whether you're the person doing the analysis or the review. So a transient in a galaxy is very difficult because the template subtraction becomes difficult. And in that case, it's better to ask for a template from the telescope that has done the observation. A transient that is very faint in the image, again, the detection can be very tricky on whether it's a real or not. Nearby stars to the source, again, you need to change the aperture. Gaps in the light curve, very few points for one of the filters. How would you compare them? And how would you check the consistency? These are just points that sort of make it harder in some cases, and we've actually faced almost every single one of these points for this GRB. And these are just a few points kind of repeating what I mentioned. This is more for people who want to refer back to the slides. And then the last step would be to publicize the data and publicize the light curve. But I just wanted to take a second to show what we've done with the review page. So we've created this wiki. This is public, and I'll send the link if anybody wants to have a look. But this is for just specifically the 29A GRB. And what we've done is that you'll find many, many tables in excruciating detail about every single filter in all the telescopes. So we first have a table about the filter, the telescope, the number of images, whether we've checked the consistency, whether we've kept the useful data, is it extinction corrected, uh, is it Sky Portal ready, and then comments. So this is for every single filter. And then we have tasks based on the telescopes, again, with comments on each one, checking if everything is up to date, consistency is checked, everything is annotated on the light curve. And then if you go down here, this is what I mentioned at the beginning that we're currently in the process of doing, which is filter by filter in very grave details what we've done and how the results from the review. So these are all comments based on the review. So removing some tasks, checking something, etc. This is filter by filter. There's some checks at the beginning. This is the same for each filter, and then comments on each one. There's some figures that refer to the comments. So we found this to pretty much be the best way to conduct the review is to have not just filter by filter, but also make sure by doing this table that we have reviewed every single image. We've reviewed every single external image as well, and put in any comments. These comments are final, so this is not okay. We need to check something. This comments is pretty much that this was done. So yeah, I'll stop here. I think we've gone a bit over time for the meeting. But if you have any questions, let me know. I'll share um, the slides and I'll also send the link to this so that people can have a look. But yeah, if you have any questions, just let me know.
Thank you, Dalia, for this very nice presentation. Any comments or question? I see. Okay, Damien.